All right. Do you agree that limits has kind of been an important thing we've been talking about ever since school started? Yes? Yes, it is the foundation of calculus. Okay? So what I want to do for just a minute is kind of brainstorm. What have we learned so far as ways to find a limit? Who can just give me an answer? Raise your hand if you know one. Yes?
By graph.
Graphing. By looking at a graph. What else have we done? Substitution. What else?
Factoring.
Algebraic. Okay, let's broaden the algebraic. There's lots of algebraic ways. Factoring is one algebraic way. What else? Conjugate. What's another? Smile method. Okay. What did we do yesterday? Do you remember? We did trig limits yesterday. So using trig stuff to remember how to do things. So we've used tables too, haven't we? Giving you table values, you fill in from both sides. So we've learned lots of different ways to do limits. Okay? Today we're going to focus on algebraic, which is what we've been doing a lot of lately, but algebraically doing limits involving infinity. Now you have already seen on your very first worksheet, limit as x approaches infinity. And that told we're supposed to look on the graph if it says x approaches infinity. Right. To the right. And if it said x approaches negative infinity, we're supposed to look to the left. Okay? Now, graphically that's not too hard. But when you're talking about algebraically, let's go back for a minute. Algebraically, what is the easiest method to use? What's the easiest? Substitution. Just plug the number in. And every other method that we did, factoring, smile, conjugate, didn't we do all that stuff and then plug the number in anyway? Yeah. Didn't we at the very end always plug the number in? Yeah. But with infinity, we've got a problem. Can you plug infinity into an equation? No, you can't. So plugging in or substitution does not work with infinity. So what we've got to do is, all right, here's an equation. I don't know what the graph looks like. How do I find the limit as x approaches infinity? That's what we're talking about today. All right? So that's the goal at the end of class. You're going to know how to take the limit as x approaches positive infinity and x approaches negative infinity. And giving you a heads up, I'm going to blow your mind a little bit today. You ready for that? Just something just kind of, whoo, that's coming later. And I like to say that so it's on the video and they know. All right. So we have to set the stage for how we're going to do this. Since we can't plug in, we've got to do something else. So to find the limit as x approaches infinity, or the limit as x approaches negative infinity, comma, we use a common parent function. To find the limit as x approaches infinity or the limit as x approaches negative infinity, we have to use a common parent function. Now, those of you who've been here for a couple of years, do you remember making your flip charts a couple of years ago? How many of you still know where they are? I had a feeling the girls would know more of where they are. Ask the boys, I don't think they would know, but I may be wrong. Anyway, the parent function we're talking about is this function here, y equals 1 over x. Okay, the whole point of the parent function flip chart was to help you remember what the parent functions are. The question is, I don't know if you guys still do. Let's kind of see. So let's sketch a little graph right here. Does anybody think they remember what 1 over x looks like? Is it the what? The Travolta one. I've never heard it called that before. I love it. The Travolta one. How many of you know who John Travolta is? Y'all know who he is? Yes. Do you know what she's referring to? The movie Saturday Night Fever. It's kind of like this. Now, it's not exactly that one. It's not exactly that one. It's this one. Do you know what I'm talking about? The one that looks like this? Okay. I wouldn't consider that's not the Travolta. That Travolta one is the cubic, actually, is what you're talking about. But I like that. I'll have to remember that. Okay. The 1 over x graph is the very first graph that you ever saw that had asymptotes. So I'm going to put little dotted lines at the end of the x and the y, because remember, those are lines that it approaches. Ooh, what else have we been using the word approaches with? Limits. What two quadrants are the pieces of this graph in? They're not side by side, not in this one. 1 and 3, exactly. So it's 1 like so, and 3 like so. Before I go any further, Mr. Giglio and I were both teaching calculus, okay? We are on the same, pretty much the same material every day, the same day. However, the way that I teach this specific concept is different from the way that she does. So if you happen to work with friends who are in her class, they may have learned a different way to do this than the way that I'm showing you. I'm just letting you know. Most of the time it's the same thing. This is one of those exceptions where it's not, okay? So just be aware of that. Now, taking a look at this graph, can you tell me the limit as x approaches positive infinity? Now that I have a graph in front of me, it's a little bit easier. Now looking at that graph, as I go to the right, because remember you said approaches positive infinity is to the right, what are the y? 0. Exactly. And then the limit as x approaches negative infinity of 1 over x. Negative infinity means look at the left side of the graph. What is it approaching? It's approaching 0. Okay? So, no matter whether you're going to positive infinity or negative infinity, for this function, it's going to 0. Does everybody understand and agree with that? Okay. Now, I need to add a little extra to this, and this says that the limit L that a function approaches as x approaches infinity or x approaches negative infinity is called, and I'm going to stop right there and let you catch up. The limit L that a function approaches as x approaches positive infinity or negative infinity is called, and you've heard this term before, we've just never associated with limits before. It is called a horizontal asymptote of the graph. Am I correct in assuming that everybody in this room has heard the phrase horizontal asymptote before? Okay, that was back in the unit that we did called radii. Y'all remember radii from Algebra 2 and Pre-Cal? The E in radii was end behavior, and that always found the horizontal asymptote for you. Okay, since both of these limits are approaching 0, the horizontal asymptote for this graph is y equals 0. So I'm going to make a little arrow right there. So for this graph, the horizontal asymptote is y equals 0. In the homework, it's going to ask you to find the limit as you approach infinity. It's going to ask you to find the limit as you approach negative infinity. Then it's going to ask you to find the horizontal asymptotes. Well, if you get this is saying that if you get a number answer here, whatever that number is, that's where the horizontal asymptote is. And horizontals are always y equals, not x equals. So if I had gotten a limit of 5 and a limit of 5, the horizontal asymptote would be y equals 5. Does that make sense to everybody?
What if they're different?
They would both be horizontal asymptotes in that case. You would have 2 of them. That does happen sometimes. Okay? Now, sometimes these will not be numbers. Sometimes they will be something else. And we'll talk about what that is when we get to that point. The one thing in calculus that's very different from any other math class that you've ever taken is that a lot of times they don't come right out and tell you. When you see a problem in Algebra 2, they say factor this. Well, you know what factor means. You know what to do. Solve this equation. You know how to solve. You know what to do. Sometimes they might just say, find the horizontal asymptote. But they don't tell you how. You need to know that horizontal asymptote is the same thing as finding the limit as x approaches infinity and x approaches negative infinity. So you're going to have to learn to start associating certain phrases with certain methods. So you need to remember that horizontal asymptote means you take the limit as x approaches infinity, because they're not going to say find the horizontal asymptote by taking the limit as x approaches infinity. Does that make sense? They're not going to come right out and tell you how to do it. You need to know how to do it. Okay? So that's what I wanted to stress to you. All right. So Now, how do we do this? How do we do the problem? That's what we're going to talk about now. To find the limit as x approaches either positive or negative infinity. So I'm going to just kind of abbreviate it, put a plus or minus on there. We are going to convert each problem to 1 over x or a variation of it. Dot, dot, dot. Okay, this is the method that I'm about to show you. And this method is very similar to what we did yesterday with the trig limits. With the trig problems, what was the fraction we were always trying to find embedded in the problem? You remember what that fraction was? Sine of x over x. And that always had a limit of what? 1. Okay? So, whatever problem you were given, you were trying to do some algebra to it to make it turn into sine of x over x. What we're going to do with these is we're going to do some algebra to make it turn into 1 over x or a variation of that. Now let me talk to you about what the variations are. Okay, what if I had the limit as x approaches plus or minus infinity, let me rewrite this, plus or minus infinity of 2 over x. Here's a variation. That's a variation of 1 over x. What if I had a 2 on top? Okay, now we're going to do this mentally. When you have a 2 right here, what does it do to that function? What does it do? When you multiply a function by something, makes it steeper. So if I stretch this thing this way, would these two still be going to 0? Yes. So the limit's still 0, even if that's a 2. Or if it was a 5, it would still go to 0. If it was a 7, it'd still go to 0. What if you had the limit as x approaches plus or minus infinity of negative 1 over x? What if we made it negative? What does negative do to that graph right there? It flips it over. So if this thing was flipped over, would the ends still be going to 0? Yes. Okay, so if the top's a positive number or a negative number, it's still going to 0. Final scenario, what if the bottom had a different exponent? What if it was squared? What if the bottom was squared? What does that do to the graph? That was the other one we wrote in the flip chart. Instead of them being like this, they're next to each other. Makes like a volcano. They'd be side by side like this. Are both the ends still going to 0? Yes. Okay? So what that means is I don't care what the top number is. I don't care what the exponent is. It's always going to go to 0. Does that make sense? So let's write that mathematically. Therefore, the limit as x approaches plus or minus infinity of any number b, I'll just say b, over x to any power n, what is that limit always going to be? What have we been saying all along? Limit's always going to be 0, no matter what. Okay.
Could it be like 1 over 2x?
Because that's the same thing as 1/2 over x.
Oh.
Yes, it could. It could. Okay. Now, this is the foundation for what we're going to do. This is the limit that we try to find embedded within the problem. Okay. Is everybody done writing on this page? Okay. So let's do a practice problem. Let me show you what we're going to do. For example, the limit as x approaches infinity of 7x cubed minus 5x squared plus 3 over 2x cubed plus 8x minus 1. Okay. Infinity limit problems are always fractions. They're always fractions. And unfortunately, when we do the work, the second step makes it always uglier than it starts with, but then it cleans up really fast and just immediately gives you an answer. So here's the procedure you're going to do. You're going to divide each term by the highest power of x. And this is when you're going to positive infinity. You divide each term by the highest power of x. Okay? What is the highest power of x you see? It's 3, right? So what we're going to do is each term we're going to divide individually by x to the third. So I'm going to write the limit as x approaches infinity of 7x to the third over x to the third minus 5x squared over x to the third plus 3 over x to the third. Do you see what I'm doing? Draw your fraction bar. Do the same thing to the denominator. 2x to the third over x to the third plus 8x over x to the third minus 1 over x to the third. Told you it was uglier. Equals. The next thing we're going to do is simplify this. I'm not ready to do equals yet. Gotta skip a line. We're going to do the limit as x approaches infinity. All right, each individual fraction, I want you to clean it up as much as possible. What is the first fraction clean up to be?
7.
Just 7. Minus. What about this one? What's that going to be? 5 over x. Do y'all agree with that? Plus, the third one I can't do anything to, so just recopy it. 3 over x to the third. Then draw your fraction bar. Move to the bottom. This one is 2 plus 8 over what? X to what power? Squared minus, you can't do the third fraction, so 1 over x to the third. Okay, now we're ready to finish it up. Okay, here's the deal. According to the properties, if you have things added or subtracted in a limit, you just take the limit of the first, limit of the second, limit of the third, and you add or subtract them together. That was what the properties told us. So what I need to do is take the limit of each one of these individually. Okay, what is the limit as x approaches infinity of 7? Okay, first of all, what does the graph of y equals 7 look like? Straight line. As I go all the way to the right, what is the y value approaching? 7. Do you agree with me? So I don't care if I have nothing to plug that into, so that's okay. That's going to be 7. Minus. Now, I want to refer back to what I said over here. This says if you're taking a limit, I don't care what the top number is, I don't care what the exponent of the bottom is. What's the limit always going to be? 0. So this is going to have a limit of 0. And the next fraction is going to have a limit of 0 over. What about the 2? Is it 0 or is it still 2? 2. It's 2 plus, what's the next one? 0 minus 0. So your answer is 7/2. We're done. Yeah, I told you it kind of finishes up really fast. So, what's going on? Anything that still has an x in the denominator has a limit of 0. And basically those terms just go away and there's your answer. Do you have any questions at this point? This isn't very hard, is it? Okay. It gets a little weirder. It doesn't get harder. The method is still the same, but it just gets a little weirder. So if I asked you to find the horizontal asymptote, what would I write? What did I tell you? If you get a number answer, that's where the horizontal asymptote is. So I write y equals 7/2. Exactly. You just found the horizontal asymptote. Move that out of the way. Any questions on that one? Okay. Now let's do a negative infinity limit. Slightly different process, not any harder. So, example. The limit as x approaches negative infinity of negative 6x squared plus 7x plus 3 over 2x plus 5. Okay, when this is approaching negative infinity, you have to make one slight little change at the beginning, and that's pretty much it. You are going to divide each term by the highest power of negative x. The highest power of negative x. So what does that mean? That means that on the bottom of the fractions, you're not going to put x squared, x to the third, whatever. You're going to put negative x squared, negative x to the third, whatever the power is. What is the highest power here? It's x squared. So when we write this, we're going to do limit as x approaches negative infinity of negative 6x squared over parentheses negative x squared, like so. You've got to write it in a parentheses like this. Now put that on the bottom of every term. Plus 7x over parentheses negative x squared plus 3 over parentheses negative x squared over 2x over negative x squared plus 5 over negative x squared. Okay, now, answer me this. If you square a negative value, what sign will the answer be? It'll be positive, right? So does the negativeness really affect this answer? No. So what I can do is I'm going to go ahead and just go back and make all these positive. But you got to check it first. What power would cause a problem? A cube would cause a problem. Or a first power would cause a problem. Okay, not really a problem, but it cleans up a little bit differently. So when I clean this up, I just got to treat it like an x squared, okay? So next step, same as before. Limit as x approaches negative infinity of, what's the first term going to be? What do you see? Negative 6 plus 7 over x plus 3 over x squared over 2 over x plus 5 over x squared. Are you with me? Okay. Remember I told you I was going to blow your mind? Here it comes. Not quite yet. Almost there. Remember I told you anything that still has an x on the bottom, the limit is what? 0. Now, let me rephrase what I'm going to say this one more time, and hopefully it'll help it make sense. The limit is approaching 0. It's not equal to 0. So keep that in mind when we do this. So we have negative 6 plus 0 plus 0 over 0 plus 0, which equals negative 6 over 0. And before today, I always told you that equals what? Undefined. But it's not. Here we go. Okay? Because this is a limit, it is not undefined. Let me show you why. If you are approaching negative infinity, this is really not 0. It's something close to 0. Okay? Because we're saying that it's approaching 0. It's not really equal to 0. So come over here, and I'm going to show you that this is negative 6 divided by some number that's close to 0. Now the important thing about that number we need to know is it positive or negative? Okay, so watch this. I want you to think for a minute. I know negative infinity is not a number, but tell me a number that you would associate with negative infinity. What's a really negative infinity kind of number? Negative 10. Even bigger. Let's go huge. Let's talk about the deficit of this country, $1 trillion. Would you say negative 1 trillion was as a negative infinity kind of a number? Okay, so if I substitute negative 1 trillion in the denominator of this fraction, first of all, what sign would it be? This fraction would be a negative fraction, wouldn't it? Okay, but it would be very, very close to what number? What's negative 2 over 1 trillion? It's really close to what? 0. That's why we wrote a 0 here. But it's really a very, very small negative number. Are you following what I'm saying? So this is really negative 6 over a very small negative number. And why is it negative? Because it's negative infinity. That's why it's negative. Okay? So that's hard to think in conceptual. So let's give this a number. Let me make up a very, very small negative number. So let's say it's negative 0.00000000007. That's a pretty small negative number, isn't it? Okay. When I divide negative 6 by, what sign will the answer be?
Positive.
It'll be positive. So this is going to be a positive answer. And what size will the answer be? If I take a negative 6 and divide it by that tiny, tiny little number, what size of an answer is it going to be? It's going to be huge. If you don't believe me, watch this. You can't see. Let's move it over here. Negative 6 divided by negative 0.0000007. Look how big that is. 8.57 times 10 to the 12th. That's huge. You agree with me? And the smaller this gets, the bigger the answer's going to get. Do you agree with that? So, in this case, what am I approaching with my answers? Infinity. The answer is positive infinity. Whoa. So, in elementary school, you were told, no, you can't subtract 9 from 4. That doesn't work. But then you go to middle school and they say, yeah, you can. It's called a negative answer, negative 5. You've always been told you can't divide by 0. Guess what I just did? I divided by 0 and I got an infinity. But it only works with limits. Okay? Now, let me address a couple questions that my first period had that I know you guys are probably milling around in your head. Does this only happen when that's a negative infinity? The answer is no. It could happen when it's a positive infinity as well. Okay? Now, here's another question. What if that was a positive 6 instead of a negative 6? Let's think about that scenario. If this was a positive 6 here, that would be a positive, that would be a positive, that would be a positive. Everything else would be the same. Do you agree with me? So that would be a positive 6 over 0 for a limit. How would it change the answer? It'd be a negative, exactly, because you'd have a positive over a negative, which is a negative infinity. Okay? Let's do another what if. What if this was approaching positive infinity instead of negative infinity, but it's this problem, right, as it is. So when I get to here, it would be a negative divided by a positive, because I said this is a positive infinity, which gives me a negative infinity again. Are you following what I'm saying? All the different what ifs. What determines this is that sign right there, and the sign of the infinity determines the bottom. Okay? Any questions? That was a little bit of a off the beaten path kind of it. Okay, so let me show you the homework real quickly. Then I'll hand it out to you. Oh, perfect. Okay, the homework is going to ask you to find the limit as you approach infinity, as you approach negative infinity, and then tell me the horizontal asymptotes. Is that a horizontal asymptote right there? Is that a number? No, it's not a number. So that is it doesn't have a horizontal asymptote. So you would put, for the part C for that, you would put none. Okay? Now, to be honest with you, you're only going to be able to, it says 1 through 12, you're only going to be able to do the first 6. I will teach you the rest of them tomorrow. Okay? Any questions?